Hello, my name is Michael, and I'll be presenting my final Coursera project for the Duke University Managing Machine Learning Projects course. Here's the opportunity evaluation. Our problem statement is that there are nearly 70,000 accidents per year just in the United States from running stop signs, and we want to introduce a system that's embedded in the vehicle to assist drivers with safety by warning them of approaching road signs. So the system needs to classify road signs and display translucent icons of the road signs on top of the mirror system. And it also needs to work internationally as well. Here are the three criteria for the evaluation of the opportunity. Is there a problem? Yes, there is. Drivers and other motorists would benefit from having this. They would be safer in their driving habits. Can ML help solve it? Yes, it can. Vision systems are commonly used in vehicles, and this is another application of that. And does somebody care? Yes, not limited to regulatory bodies, governments, law enforcement, and insurers. And there's possibly an opportunity here to partner with the insurance industry uh, to give owners of this device a discount in their insurance. Here's the CRISP DM business understanding. The problem definition is on the left here. Target user is the driver of the vehicle. The problem is that missed road signs result in hazards to the driver and other motorists. Why does it matter? Because accidents can lead to injury, loss of life, and or loss of property. And the current state is that drivers must visually see all these signs and comply with them in the environment, and they're often distracted by their kids or their phone conversation, the radio, whatever it is. Define success. Expected impact is safer driving conditions for motorists. The metrics that we would evaluate this on would be reduced number of insurance claims and cost of the claims. Some of the targets would be, a to be determined fraction of the old claim. We would want the new number of claims to be less than the old by some percent, and also the cost as well. Constraints. We must run in embedded environments, and there is a low opportunity to be able to update the software in the future since it's embedded and in the field, and potentially a third-party add-on to the vehicle, and so we need to get it right the first time. Relevant factors: lighting, weather, angle of view, occlusion of signs, differences between regional and international signs that may look similar. So what does the solution look like? We're going to use existing road sign databases. High quality images exist. We'll leverage those. We just need to figure out how to obtain them. Convolutional neural networks for the technical solution. We'll use deep learning to solve any type of vision problems that we may need for this. And we intend to evaluate existing architectures, identify and create appropriate neural network architecture for our edge computing needs. We have to run in embedded environment, and so this needs to be quick, and so we'll make a list of what's available, try them, and see what's feasible. For validating the solution, we want to collect user experience data through a mock-up in a simulated driving environment. For this mockup, we don't need any machine learning since the simulator knows where all the road signs are in the simulated environment. We can simply write code to display these images in the rear view mirror area of the simulator. And we would use this to get feedback from drivers on what they like about this system, what they would hope to see improved, and so on. Good machine learning practices, cross-validation, diverse training, maybe having a separate test set of pathological cases as well, just to see how models perform. And then finally, once we have a device in the field, we would do field tests and see what kind of training serving skew there might be, and also collect additional feedback from users. The system design, what does it look like? Is it cloud or edge? Definitely edge because it's embedded in the vehicle. Is it online or offline learning? It's offline. We're going to use a database of road signs and then only do a classification, object location sort of problem while in production. And so we don't have online data that we update training with. Batch versus online predictions. The predictions will definitely be online. We need to provide the information to the driver as soon as possible. What are some of the potential risks in production? Training serving skew, high risk due to weather conditions impacting visibility and occlusions of signs by objects, trees, branches, or vehicles. It's always changing as the car moves around and the pictures look different. So our mitigation for this is to have a very diverse training data set and have pathological cases for testing these issues. Latency is a medium risk due to the edge environment and the need to continually provide results. Our mitigation is to optimize the CNN architecture for embedded environment, try things like MobileNet v2 and other state-of-the-art algorithms for lowering latency. Data drift we see as medium low due to the unlikely event that road signs will change their appearance in the near future. And concept drift we see as very low due to the fact that road signs are probably going to still remain. Autonomous driving may eliminate them at some point, but for now, they're here to stay. So that's it. I want to thank you for your attention, and I enjoyed the course, and I hope you did as well. Have a great day.